Okay, ladies and gentlemen, welcome to this webinar sponsored by the American Center, the American Peace Information Center, with Dr. Christopher Busby on the topic of uranium weapons and their danger in Europe. Dr. Busby he received the PhD in chemical physics in 1981 from the University of Kent. Before that, he was elected a member of the Royal Society of Chemistry. He is also a member of the Royal Institute of Chemistry, the Royal Society of Medicine, the International Society for Environmental Epidemiology. He's a member of the Department of Health committee examining radiation risk from eternal emitters. He has been a member, that is, of that committee. He's been a member of the Ministry of Defense of the UK Depleted Uranium Oversight Board, and he is scientific secretary of the European Committee on Radiation Risk. He has served as an expert witness in 80 court cases in the United Kingdom and the United States on the health effects of ionizing radiation, including a case at the House of Commons and elsewhere. And for A-bomb veterans and veterans of the Persian Gulf War, including cases in the UK involving the health effects of internal radiation from depleted uranium. He has been commissioned to provide expert advice in 20+ UK and UN and other governmental agencies. He has published approximately 50 peer-reviewed papers and many books. So with that, I introduced Dr. Busby and let him explain this problem to us, which is already produced radiation in Europe through the explosion of uranium weapons in Khmelnytsky, Western Ukraine. Thank you. Dr. Busby, you're on.
Good. Can you hear me now?
Yeah.
Yeah, all right. Well, just let's leave this slide here for the time being. First of all, I'm grateful to you all for giving me this opportunity to summarize some of the problems that there are in the world at the moment associated with depleted uranium. I had rather hoped that the depleted uranium problem would go away after all the work that we did after the Gulf Wars and the effects that were found there, and the effects that were also found in other places where uranium weapons were being used. But apparently this wasn't to be. And the reason for this, of course, is because uranium weapons are magic bullets when it comes to the issue of tank warfare. And it was quite clear in the Gulf War, the first Gulf War, that tanks were no longer an important item on the battlefield. The Iraqi tanks, a lot of these tanks were Soviet tanks, the same tanks that are being used in Ukraine at the moment, were very easily destroyed by really quite small depleted uranium penetrators fired from underneath the wings of American aircraft that used Gatling guns. These were the aircraft that fired Gatling gun rounds, and I'll talk a bit about that. But before I start, I think I want to address a number of questions that were put to me, and I thought I'd start with those. And the answers are, because I don't want to run out of time at the end and then have to gabble my way through them. And these questions are really quite important ones, so I'd like to address them right at the beginning before we get into the stuff that I'm going to say about the history of depleted uranium and the mechanisms of its effect and so forth.
And you see these?
Yes.
So yes. These are the questions, right, Dr.
Okay.
Busby?
Right, I'm going to address these questions rather briefly, and the importance of what I say will become, you know, the issue will become more clear in following my PowerPoint presentation. Well, first question is that the UK has sent depleted uranium or uranium weapons to Ukraine, has trained Ukrainian soldiers on their use. What is the importance of this? The importance of this is that we're back in the same mess that we were in Iraq and in the Balkans. And it highlights an issue which is the most important issue in this area, which is the question about the effects of uranium on health. Now, the British and the Americans have a system of analysis of radiation risk, which was developed around about the time of Hiroshima. And this is a very primitive method, although a very powerful method, to assess the health effects of ionizing radiation exposure. And on the basis of this method, which is what's called a radiation risk model, which hasn't effectively changed since 1952, when DNA was discovered, we have a measure or a quantification of radiation effects in terms of pure energy. That's energy per unit mass. And they call this dose, they call this absorbed dose. So the importance of the fact that Britain has sent, and America is shortly to do this, uranium weapons to Ukraine, means that they are consistently maintaining that the method of analysis of the health effects of radiation, the one that they use at the moment, is accurate. Now, the problem is if it's not accurate, then two things are clear, and obviously these two things are real things which are going to happen. One is that the health effects of the weapons that are going to be used in the Ukraine are going to be serious and massive in the populations of the areas where these weapons are used, and in the areas where the gases, the aerosol particles end up once the weapons are used. So there will be increases in cancer, congenital malformations, decreases in fertility, all of the stuff that we've seen and that I will talk about in my presentation in Iraq and in the Balkans and in other places where these weapons are used. So what's going to happen is that if these weapons are used, and in fact, at the moment, I'm going to suggest that they have already been used, and the storage sites where they have been placed have been blown up by the Russians. And so the particles from these materials are already dispersed around Europe. And so and that's very bad. And we know, and we certainly know that they've got to UK because I've studied that and found high levels or significant levels of uranium in the filters in England. So this goes on to the question of the huge explosion of the ammunition depot. And some say that British uranium weapons were stored there. And I believe that is the case. So as far as that's concerned, I believe that there has been a cover-up, that there have been increases in radiation measured at the European detectors all over Europe, certainly in Poland, and I'll show some pictures of those. And so people have already been exposed to these particles, and there will already be some increases in congenital malformations and all these genetic effects that I'm going to talk about and have spoken about. Now, what is the lifespan of the radiation from uranium weapons? Well, that's an interesting question, because we have to split it down to two things. First of all, the lifespan of the uranium, the half-life of uranium is 4.5 billion years. So pretty much it's going to be there forever. The radiation from the weapons is going to be wherever it ends up. But the problem is if it ends up in people, it will stay in the people largely. I mean, we've done studies with mice, or I've been involved in people who've done studies with mice. There's plenty of evidence that once these particles get inside you, they pretty much stay there, or at least a good proportion of them do. So that means that they're irradiating you for the rest of your life. And that causes all sorts of effects, including cancer, including effects on children, on fertility, and on genetic transfer problems to your children. Now, the lifespan of the radiation from uranium weapons has to include the lifespan of the genetic damage that occurs. So, in other words, if somebody inhales these particles and they produce genetic effects in the germ line, those genetic effects go to the children, and then they go on to their children, and they go on to their children more or less forever until some person dies without issue. So this is a very, very serious problem in terms of the lifespan. So it's not just the half-life of the uranium, which is more or less forever. I see we're having a question here. Would chelation help? Well, probably not, I think, or possibly slightly. The problem with uranium as a particle is it won't be removed by chelation. The uranium ions might be removed by chelation, but what we're dealing with here is particles, and particles are going to sit around in the body. So to the next question, what's the effect on soldiers who advance to an area with uranium dust? Well, of course, they will inhale the uranium dust and get inside them, and they'll all end up like people, or some of them will end up like the people that I've represented in court. And those people suffer all the effects that I've been talking about. So in other words, their children have genetic damage and they get cancer. I mean, I'll discuss an issue. I'll discuss a particular soldier who was exposed to depleted uranium when he was cleaning tanks in the first Gulf War, and he died of colon cancer, and I'll talk about that later. So increases in all of these genotoxic based diseases. Is there anything they can do to prevent absorbing uranium dust like a gas mask? Well, no, because these particles are so small that they can more or less go through any gas mask. I mean, if they have a respirator, of course, then that would work. So if you were carrying a cylinder of oxygen or something and you were completely isolated from the environment, then you would be okay. You wouldn't inhale the uranium dust. But nobody does that because it's too costly and complicated, and you can't fight a war with a cylinder of oxygen on your back and a sort of respirator. How long does a tank that was hit with uranium shell stay radioactive? Pretty much forever. Because as I said, the half-life of uranium is billions of years, and every time a uranium atom decays, uranium-238, it decays to thorium-234, which is a beta emitter. Uranium is an alpha emitter, so it decays to a beta emitter, thorium-234, which has quite a short half-life, about 20 days. And then that decays to another beta emitter, protoactinium-234M, which has got a very short half-life, minutes. And that decays to uranium-234, which has a very long half-life. So you have decay, and then stops decaying. So what that's called is stochastic equilibrium. So that means that for every decay of uranium, you get 2 beta decays, and these are also partial gamma emitters, 6% gamma emitters. So in other words, 6% of all of the radiation occurring when a uranium particle when uranium atom decays, 6% of it is a gamma photon. So when a uranium-238 atom decays, it goes bip, bop, bop, and the bop bops are very quick. They're thorium-234 and the protoactinium-234M. The reason I raise that issue is because people always say that uranium-238, depleted uranium, is not a gamma emitter, and so it's perfectly safe to handle, and it won't be detectable on a Geiger counter. This is nonsense. I mean, I've measured this stuff in Iraq and in Kosovo and all over the place, and it's got a very, very strong gamma photon signal, so it will make a Geiger counter go crazy. And the reason for that is that 6% of it is gamma radiation. And so, although you might say 6% is not very much, if you've got a ton of it in the first place, then 6% is quite a lot. For example, the specific activity of uranium-238, DU, if you like, is 12.4 megabecquerels per kilogram. Now, this stuff is very dense, so it has a density of 20, and so in other words, 100 cc's of it weighs 2 kilograms. So of that 12.4 megabecquerels, that's 12.4 million disintegrations per second. Try and imagine that. So you've got a piece of uranium the size of my finger, and that's effectively the bullet that's fired from the Gatling gun. And that bullet, and there are plenty of them lying about in Iraq, or there were when I was there in 2000, and they were bullets that had been fired in the first Gulf War, and they were lying around on the ground, and children were picking them up and playing with them and so on. So if that was a kilogram, then you've got 12.4 million disintegrations per second, 6% of which are gamma photons. So in other words, of those disintegrations, 7,200 disintegrations are gamma disintegrations. So you've got 7,200 clicks per second on a Geiger counter. So that's certainly radioactive. Okay, and also the other thing about inhaling uranium dust is it destroys your lungs. We've lots of people done experiments on uranium dust with animals, and they cause lung fibrosis. So anyone inhaling, soldiers, for example, inhaling uranium dust will get very bad problems with their lungs, as if they had bronchitis or if they had TB or whatever. There'd be lung inflammation problem, and they'd be coughing and not able to breathe properly. And I believe that there is supposedly some evidence that that there are effects on a sort of tuberculosis epidemic in soldiers in Ukraine at the moment. Now, what's the difference between uranium weapons used in Serbia and the 1999, the ones used in Iraq 2004, and the ones we sent to Ukraine now? Well, the governments would say, the US and the UK would say they're the same weapons, essentially. That's what they would say. What I would say is that they have developed a sort of like a fourth generation or third generation or whatever generation set of weapons that involve a new mechanism, a new process. So there are two issues here. The first is that they're almost certainly using uranium as a shaped charge in handheld anti-tank missiles. And the shaped charge, the missile flies over the tank and fires downwards and blows the tank up. It's really quite alarmingly spectacular. In fact, I've seen videos of this happening where the guy shoots a missile at the tank, and the tank's about 600 meters away, and the tank just disappears. Just there's nothing left. So I think they use some sort of uranium shaped charge, and they use those in missiles as well. But also, and I will mention this when I come to talk about these things in the presentation, there is some evidence that there is a completely new weapon involving uranium or producing enriched uranium, because we found an enriched uranium signature in craters in the Lebanon, and also in other places where we've been on battlefields. So there's some mysterious new weapon which I have a few ideas about, and I'll briefly cover. But basically, the ones that they're talking about sending to Ukraine, and the ones that the Americans are going to send to Ukraine, are the good old-fashioned uranium rods with a sabot that they put inside a tank gun, and or an anti-tank howitzer or field gun or so on, and just shoot it at the tank. And when it hits the tank, it goes straight through it, more or less, because these uranium rods, when they hit the target, they burn at very, very high temperatures, and they just burn. They're self-sharpening. They burn their way through into the turret, and they just roast everything inside the turret. And so when you find what's left of inside of the turret, you have things that the Americans, when I talk to them about this, called crispy critters. Those are the men who were inside the tank when it was hit. And these things are so powerful that they can go right through one tank, out through the other side of the turret, and hit another tank and destroy that. So they were having a lot of fun in Iraq, what they call plinking tanks. Okay. And of course, how does it affect children who play with a damaged tank? Well, there's huge increases in leukemia in Basra and in other places where children were playing with damaged tanks, and presumably also in Kosovo too. I'll show some pictures of that. So where we are, Wikipedia. This is the journal article about Hadithi and so on. UNEP. Well, I have to say, well, that UNEP thing is not about Iraq. It's about Lebanon. And the study, but the past studies of birth defects in Iraq, concluding that there was no clear increase in birth defects, that was a disgraceful study that was carried out by some Iraqis with the support of somebody from the London School of Hygiene and Tropical Medicine in London. But what happened is that after I did my Fallujah studies, I became very, I know famous, but infamous or whatever. But but I'd raised the issue. I was the first person to show that there was these increases in congenital disease and cancer after uranium weapons were used. And I presented this on behalf of the Arab jurists at the Human Rights Council in Geneva, United Nations Human Rights Council. And I met with the head of the International Red Cross too, and talked about it. And so there was a lot of hoo-ha. There was a lot of concern about what I'd found, and everyone was jumping about and saying that it was a war crime and so on, which it was, of course. And then I was approached by some Iraqi state medical people, head of medicine or medical department in Iraq at that point that was more or less controlled by the Americans at that point. And they said, would I work with them on a study of the whole of Iraq to see if these effects in Fallujah that I'd discovered were universal. They said, oh, we're very worried about all this and we really have to look into it and so forth. And I said, yes, okay, but I have to be in control or involved in the design of the study, because I've worked in this area for such a long time that I know there are a lot of crooks involved here. And of course, nobody wanted to really concede that there were all these horrifying effects following depleted uranium. So presumably the American masters got in touch with the Iraqi state and said, look, try and do something about this. So they said, well, no, we're not going to allow you to be involved in the design of the study. And so I said, well, I'm not getting involved in any of it. Then you can go and do your own study, which they did. So the study they did was it was a questionnaire study. It was preposterous. So what they did was they went and they asked all these mothers all over Iraq whether they had any children with congenital malformations. And so, of course, they said yes or no, or whatever. But the problem is that you can't tell if your child has died from a congenital malformation, because most congenital malformations are invisible. The child just dies. And these are people living in all sorts of small villages and places where there was no proper healthcare. And of course, they said the child died last year, but we don't know why. So that was registered as just a child who died. And so, because, if you have congenital malformation of a child, it's mostly something wrong with the kidney or something wrong with your heart or whatever, and the child just coughs and coughs and coughs and then dies. That's it. So the study itself was fundamentally flawed, but nevertheless, they published it and they said, oh, well, we haven't found anything wrong. And also, it was pretty insane, really, because they found that the levels of congenital malformation in Iraq were lower than they were in the control regions like Egypt and Jordan and the other places. So I've got no time for those people. And as far as the United Nations Environment Programme are concerned, we did some joint studies with them on the uranium levels in Lebanon, and they just lied. We split samples. We gave them half the sample. We took off half the sample. We analyzed the sample in 2 laboratories in England. I paid for that, or we paid for that. And they found one thing, and the UNEP found totally the opposite. And the other thing is, when we went to Kosovo, I went to Kosovo in 2000 with Nippon Television, because they wanted to see if there was uranium being used in Kosovo, in the Balkans. And at that time, the United States said, no, we didn't use any uranium in that area. And then UNEP went along, a chap called Pekka Haavisto, who is now, I think he's now the foreign minister of Finland. So he turned up with his team and they looked around and they couldn't find any uranium. And then we went and we found the uranium and we published it, and we did a program on it on BBC Two and also on Nippon Television. So I don't have the problem with the United Nations is that they're not an independent outfit. You know, they're controlled very largely by the United States, so they do as they're told. And so, and the same thing happened with Sergei Skripal. You know, all this Novichok nonsense when he was supposedly poisoned by Putin. And also Litvinenko, that was another one where they were all involved in trying to show that the Russians had poisoned somebody. But there was no evidence at all, but they cooked up the evidence, and that was UNEP that did it. So I don't have a lot of time for the United Nations Environment Programme. I don't really trust them. And I'll talk a bit about the cover-ups as we go through all of this. So that's basically my answer to the questions. I thought I'd get those out of the way right at the beginning in case I have to sort of, you know, do it right at the end. So there we are. So we'll get on with what I want to say now. So can we see the second slide? Okay, well, that's just a flash piece of me sitting on a tank in Kosovo. So I'm going to divide this presentation into three parts. First, I'm going to start off with the mechanisms and talk about how it is that uranium exposure really cannot be described in the same way as radiation is described in the current risk model. So I'll do that. The risk model has completely failed. And that means that people, just ordinary people, are all the time being exposed to radioactivity from Chernobyl and from Fukushima and from nuclear weapons testing and so forth, that has already caused, and I've written a paper on this, which was published last year, has already caused more than 300 million deaths from cancer since the beginning of the radiation age. And this is probably the worst public health scandal in the whole of human history. It's really, really not good. The human race has been genetically damaged by the splitting of the atom and the subsequent dishonesty associated with analyzing the evidence relating to exposure in terms of genetic damage. So then I will talk about the global dispersion and health effects of uranium weapons up to 2004. After that, I thought it was going to stop because I believe the European Parliament banned it, and it was supposedly not ever going to be used again. There was a huge outcry about all of the things that basically I found originally, but other people also found similar things, both in mechanism and in epidemiology. And
No, they didn't ban it. They didn't ban it. It was vetoed by the UK and France.
Yes. Okay. But anyway, I still thought that was it. I thought that we'd had enough of depleted uranium. In fact, I mean, I was quite surprised that it all came back, and I was had to go back wade back into this swamp to talk about this stuff all over again. But obviously, I have to do that, and this is why I'm here. So then I'll say a few words about the things that I found, you know, the Fallujah stuff and so on, and then I'll say a few words about the new deployment of uranium weapons in Europe after the Ukraine war, because I found some very important things there as well. But you know, real things, not stuff that is just arm waving. You know, it's not just what I think; it's data, and all of these things are data. I mean, the point about science is it relies on data. You know, you looked out the window to see what's happening. You don't just make it all up and wave your arms in the air and say there's no problem. You have to go and look and see what happens to people after they're exposed to depleted uranium weapons. And that's what I did. And so this is what I'm going to tell you about. So next slide. Okay, now, first of all, I just briefly say that there are limits based on the risk model that I was talking about, the one that's wrong. And because uranium is a very, very long-lived radionuclide, because it's a very weak alpha emitter, it's considered that you can on the basis of the dose that it will produce, because there are laws about dose. The law about dose is that you can't receive more than about the same dose that you get from natural background radiation. But of course, that's a different sort of dose. It's calculated differently. So here are the limits that they give you. And these are the limits. You're not allowed to be exposed under the law to more than these levels in terms of milligrams, okay? But as I will argue, or as I have shown, well below these levels, there's full saturation of the DNA by uranium as a uranyl ion, UO2++. Next slide. So the radiological risk model, that is to say, how much radiation you can get in order, to be safe or to be considered safe, it is assumed, because of, like I said, this very low radioactivity, it's assumed to be a low cancer risk. And the target organs are believed to be the kidney, the lung, and the bone. And I said before, it has a specific activity of 12.4 megabecquerels per kilogram. So 10 milligrams is about 0.1 becquerels per liter. And so if you look at the ICRP dose coefficients, ICRP is the International Commission on Radiological Protection. So they basically define the limits that you're allowed to be exposed to. And they do it on the basis of this issue of radiation being assessed as energy per unit mass. The reason that this is absurd is that if you were to take heat energy per unit mass, you could sit in front of a fire and you could say your body was 70 kilograms and you could take so many joules of energy and you could divide it into your body and feel really quite warm and pleasant, if it was a cold day outside. So, and your dose would be 70 joules per 70 kilogram would be 1 sievert. Okay, and so then that's how they do it. But of course, the problem is that if you reach into the fire and you take out a hot coal and eat it, that you'd get the same dose, but you wouldn't get the same effect. And that's the problem. That's the problem essentially with external and internal radiation and the use of the ICRP risk model to assess exposure to uranium particles or plutonium particles or any particle really, because these particles put an enormous dose into a very small area of tissue, a very small volume of tissue. Whereas if you diluted it over the whole body, it becomes a minute dose. And this is the problem. It's a very simple problem, really. So this is why the Royal Society and the World Health Organization and the physicists associated with the military and so on, they dismiss the fears of the Gulf War veterans. And it doesn't matter how many Gulf War veterans die of cancer, they say that it can't be caused by the uranium. Okay, next slide. So this is the fatal problems with the model. The model assumes that absorbed dose energy per unit mass is an accurate measure of risk. So the decays from a particular uranium particle, that's uranium particle, are short range. They're only like 4 cells. These alpha particles only reach 4 cells when they stop. So the doses near these micron-sized particles can be enormous for the local tissue volumes within range of the decay. So we pointed this out in the European Committee on Radiation Risk, and we argued it in the government committee and all over the place, you see. You can call it the hot particle problem or the second event problem. Second event means that you can knock the DNA and then it tries to repair itself, and you knock it during the repair cycle. Repair cycle is about 12 hours. Next slide. But there are new results from laboratory research. I mean, this laboratory research began round about the time of the Second Gulf War, when the health effects of uranium began to be highlighted, and even the American military started to look at this and to see whether there was some issue, and they found there was. A.C. Miller, Alexandra Miller, she works for the American military. And she showed that uranium causes genetic damage in cell cultures at concentrations where there are no significant alpha emissions. So something's going wrong there, something funny. And she also found that uranium particles cause genetic changes in cell culture elements and cancer in laboratory animals at tiny, tiny, tiny concentrations. And then the French found that uranium causes lung inflammation and kidney inflammation and brain inflammation and all sorts of problems in rats, and produces chromosome damage in miners and Gulf War veterans. That was shown by Heike Schroeder, who's dead now. She was a friend of mine. And there was a chap who worked in the Congo, Zaire, who found chromosome damage amongst the uranium miners. So my explanation, which I developed in about 2006 when I was working on this for the Depleted Uranium Oversight Board, is these effects a consequence of photoelectron production by uranium. And I can explain that. So go to the next slide. You will all know, or some of you may know, that when light falls upon a metal, if the light is energetic enough, and blue light is more energetic than red light, because the energy in light is associated with its frequency, with its wave, in 1/, is inversely proportional to its wavelength. And this is why photocells work. So you have photoelectric cells, so solar cells, if you like. When the light falls on them, they produce electricity. They produce electrons. The electrons fly off the. This is how your light meter works on your camera. Those of you who are old enough to have a camera where you needed a light meter, of course, nowadays, these things are all built into your digital camera. But in the old days, we used to use light meters in order to tell, you know, what level of aperture and stop, how much light to let into the film. So this is the photoelectric effect. So if a radiation photon hits a piece of metal, it shoots off an electron. And an electron is the same as radiation. A beta particle is the same, is an electron which whizzes off from a beta emitter, and it smashes into tissue and it ionizes the tissue, and if it hits the DNA, it knocks a hole in it, okay? And that's not good. So but as far as uranium is concerned, it's present in the body either as a particle or as the uranyl ion, okay, or a nanoparticle. These particles from depleted uranium and from weapons testing are between about 50 and 300 nanometers, so they're smaller than the wavelength of light. Wavelength of light is between about 300 and 1,000 nanometers, visible light, that is. So they're very small. That's why they get through gas masks, and you know why they get into your lungs, and when they get through the lungs into the lymphatic system, and then more or less they can go anywhere and get trapped. And if you inhale, if you swallow one, it can get into your colon, and it get trapped in the colonic epithelium, in the inside of the little wiggly bits inside the colon, and it'll just sit there forever, banging off its alpha particles and so on. But more than its alpha particles, what it will do is it will produce photoelectrons. As soon as external gamma radiation, and we all live in a gamma radiation environment. So if I switch on my Geiger counter, it will go click, 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 and that's gamma radiation going through my body. Normally it goes right through my body and out the other side. Some of it is absorbed, and the amount that's absorbed causes ionization, which can lead to genetic effects and so on. But the uranyl ion, UO2++, binds strongly to calcium ionic binding sites. So it follows calcium as a sort of periodic table thing. And of course, calcium binding sites are bone and teeth, which is why uranium ends up in the bone and in the teeth. But most important for radiological purposes is that it ends up in the cellular DNA, because the DNA is a calcium backbone systems, calcium phosphate, and then you have the DNA bases stuck onto it. But the backbone is calcium phosphate. And so the uranium's the uranium exchanges with the calcium and sticks to the chromosomes. This has been known for a very long time. In the 1960s, Huxley, the famous Huxley, the biologist, started to use uranyl acetate or uranyl nitrate as a contrast stain for chromosomes in electron microscopy. So in other words, because the uranium blocked the electrons, and it blocks the gamma radiation. It absorbs it preferentially, gamma. So the absorption of gamma radiation and X radiation, which is known to be proportional to the 4th or 5th power of the atomic number, gives uranium some kind of ability to intercept all the background radiation that normally would go right through your body and shoot out beta particles, shoot out electrons. And the reason for that is that it's got this high atomic number, and as I said, the interception power of an element is proportional to the 4th power of the atomic number. Next slide. Next slide. Yeah. Okay. Well, this is just a rough example of the fourth power problem. Okay. So in other words, water, DNA phosphate, the approximate, you can say the approximate atomic numbers here are Z. That's not quite accurate, in fact, but anyway, it's roughly accurate. Calcium's 20 and uranium is 92. So you can see that if you go right to the column on the very right-hand side, you can see that uranium absorbs gamma radiation some 500,000 times more than water. And that's a big deal because we're mostly made of water. And so if somebody shines some external gamma radiation on us, it normally goes through us. But if we've got uranium in us, then the uranium blocks it. This is why radiologists wear lead aprons, incidentally, because that's also got a high atomic number and the lead blocks it. Blocks the radiation, stopping it getting inside your body. But just imagine if you had all these little particles of lead inside your body, then of course it would block the radiation, but it would not just block it, because then the photoelectrons produced by the interception of the radiation would then fly out of the lead particles as they fly out of the uranium particles and cause genetic damage, in this case, destroy the chromosomes, because the affinity of the uranium for the chromosomes is very great. Next slide. So here we are, the affinity concept. This is all a bit complicated physical chemistry, really, but effectively what it means is that the uranium sticks on the chromosomes. This is just a bit of chemistry, really. And Huxley and Zubey, they were the first people to use the DNA stain. It said takes up its own dry weight in uranium from 2% fixing solution. So in other words, if you put those cells into a 2% solution of uranium nitrate, then the DNA takes up its own weight in uranium, and which sticks to the DNA. Of course, that's not going to be good, because DNA is not, something that we don't want to have uranium stuck on. Next slide. Okay, so that's the same thing. I've just more or less said that. So uranium oxide particles from, yeah, well, let's go back to the previous one. Oh, is it? Yeah, next one. This one. Now, this is a very interesting study that we did. I had a student called Andreas Elsaesser that I worked with in Ulster on this problem of these uranium particles. And he did one very clever thing. He used this Fluker computer program, which is a monstrously complicated and nightmarish computer program, which enables you to study things using mathematics to sort of predict what would happen if you did this or that and so on. So what he did was he programmed 10 nanometer particles, and these are the particles. You can see water on the left, gold in the middle, and uranium on the right. And he shot 1,000 primary photons at the gold, 1,000 primary photons at the uranium, and 100,000 primary photons at the water. And you can see quite clearly here that, so water is on the left. Now, if you had 1,000 primary photons in the water rather than 100,000, you wouldn't see any particle tracks at all. So just bear in mind that he shot 100,000 photons into the water particle, but 1,000 into the gold and 1,000 into the uranium. And you can see quite clearly here what I'm talking about, which is that the uranium produces a lot of electrons, a lot of beta particle electrons, and these electrons whiz off, and they can hit anything, of course, within the range of the electron, and then they can cause ionization and damage them. And of course, you can see if that uranium particle is sitting close to DNA, then it's going to blast a hole through the DNA. It's like a little bomb. Okay, and we published this in 2012. Next slide. So, and it's not really a new idea. It was just that this was my idea it was a new idea for me. But when I looked into it, I found that there were lots of papers in which photoelectrons were used to increase the effectiveness of X-rays and gamma rays. So in 1999, this guy Herold and his team were using 400 nanometer gold particles to enhance X-ray doses to tumors. And various the most important one was this one by Regular, who measured a 100-fold photoelectron enhancement near a very thin gold foil. So although we did this computer program proof that this happened, people have actually studied this in the past. You can see that 1949 was the first one when Spears was looking at effects on bones because of the calcium. He found a 10-fold effect due to the interception of the X-rays by the calcium in the bone. And in fact, that's why X-rays work. The reason that when you find an X-ray for somebody and you can see their skeleton is because the skeleton intercepts the X-ray because of the calcium in the bone. That otherwise it wouldn't work. So it's a real effect, and it really associates. It really is applicable to the health effects of uranium. But of course, nobody has done anything about it. And the Ministry of Defense have just basically ignored it. And we still have a situation where they're using these depleted uranium weapons. Next slide. Okay, so let's look at actually what happened when they started using them. So I went to Iraq and I wondered about the place, and I went to various hospitals and I looked at cancer data, and I measured the uranium in the tanks that was still in the tanks after 10 years of sitting about in the desert. This was with Al Jazeera. Next slide. And of course, the problem. Yes, well, this is just argue that the problem is covered up by the United Nations, because in once all these problems associated with internal radiation started to appear as a result of the nuclear weapons testing and all the fallout that was falling in America and the United Kingdom and all over the place, the doctors who were concerned about this, that's the World Health Organization, if you like, were taken away from the research on the effects of radiation, and it was put in the hands of a new outfit called the International Atomic Energy Agency. And the IAEA's remit was the safe use of nuclear power. So really there was a problem there. There was a conflict of interest between the World Health Organization and the IAEA, but all of this, the effects of radiation are still in the hands of the IAEA and not in the hands of the doctors. And this is why the true effects of the Chernobyl disaster and also Fukushima and so on have been covered up. You can see here a picture of these children who are playing with these wrecked tanks and down in the area of the depleted uranium use in Al-Basra in the south of Iraq. Next slide. So the question is, why is it used? I mean, what is it? What's the point of it? Well, the point of it is, as I said before, it is a silver bullet as far as tanks are concerned. These are some pictures of the bullets that we found in the southern Iraq. These are Gatling gun, A-10 Gatling gun penetrators from the Warthog aircraft that were firing them. And it was believed that 350 tons of DU was used in 1991 war, and the Navy almost 2,000 tons in Gulf War II in 2003. And also, I have a lot of evidence that the material began to be employed in some kind of bunker-busting bombs and hard-target cruise missiles after 2001. We found some interesting effects in Bosnia and Kosovo that suggest that. But of course, they won't concede it. They won't admit it. So, in fact, there was a German doctor who tried to take one of these bullets back to Germany. He's dead now. I can't remember his name, Hans Dieter something or another. Anyway, they arrested him at the airport, talking about radioactivity. The airport radioactivity detector found the bullet inside his suitcase, and they sent him to jail. Poor guy. He was a good guy, that guy. He was a really good doctor. Anyway, next slide. So yeah, so I looked at all sorts. There's a picture of a hole there. That's a hole produced by one of those A-10 Warthog penetrators. And if you put a Geiger counter near there, it goes completely mad. It goes right off the scale. So I looked at cancer in Iraq at the time. Next slide. No, I don't. This is not. This is just comparing the DU and other radioactive contamination. I mean, the thing about radioactive contamination is, although DU is a very weakly radioactive substance, there's an awful lot of it. There's hundreds of tons of it, and so however weak it is, it still produces an awful lot of radiation. Next slide. Yeah, next, not this is just also comparing uranium and plutonium. This is me measuring it in Iraq. Next slide. And there's that hole that I was telling you about, and that's, yeah, next slide. And that's measuring it in Kosovo. So this was at a time where the United Nations Environment Program went there, and they didn't find any, and they denied that it was being used. So they came out on on the media and said that nobody was using, that the Americans were not using uranium in Kosovo. But anyway, we found it there, and we measured it, and we took it back, and we were on the news on this issue. So next slide. And these are the children who are in Kosovo playing around. Aren't they nice? Okay, they were playing around in Jakova near the armored car that I showed you in the previous slide, and I measured 5,000 becquerels per kilogram of DU emissions in the dust in the park where they were riding about on their bicycles. And of course, they're just kids. They play around there. They pick up the mud and they throw it at each other, or they bite their fingernails and so forth. Then they die. Next slide. Okay, these particles travel a long way. That's another thing that the Ministry of Defense deny. They say that and they bring in all sorts of bogus information bogus data to say that the stuff remains more or less at the site of impact. But in 2006, I decided to have a look and see whether there was any uranium in Aldermaston in England around about the time of the Gulf War. Aldermaston is the atomic weapons establishment in England, and in 1990 they were forced by law to measure uranium and plutonium in air filters around the plant, and also at a distance of about 15 miles from the plant. And the reason was that there was a huge increase, there was a significant increase in childhood leukemia near Aldermaston. And so they had to prove, if you like, they had to have online, continuous data to show that they weren't releasing stuff that could cause childhood leukemia. So they set up these high-volume air samplers around in two rings, one close to the site and one about 15 miles away. And of course, therefore, obviously, if the levels went up near the site and not further away, it was not a global effect; it was an Aldermaston effect. And they've been doing this ever since. But anyway, at that point, I decided to ask them for the data and to see if there was any effect. And they had to supply it. They first of all, they left out the bit when the Gulf War, because they knew, of course, they knew what I was after. But then I complained to the Information Commissioner, and they coughed up the results. And we found that there was a significant increase in uranium in the air at the plant and in the control sites 30 miles from the plant. So in other words, this was a global increase in uranium. And it happened at the time of the Gulf War. This was the 2003 Gulf War, and so that became quite a famous story. So it got into the front pages of the Times or the Telegraph or some newspaper. Of course, that wouldn't happen now because there's such a massive cover-up now that you can't get anything like that published in any newspaper or on any TV program or anything. So next slide, and you will see the increase. Here it is. At 0.58.5, that was the graph. That's all of those are all the different filters. They're different, four different sets of filters there, and so you can see that increase at the time of the Gulf War. So next slide. And yeah, and we were not the only people to find increases. This is a paper published by a guy called Kerekes, and he showed that there was an increase in uranium in southern Hungary after the Balkan War, or during the Balkan War here. So there was a significant increase in activity in uranium there. Dust concentration of airborne particles up to 2.5 microns. Next slide. So the point about all of this is it gets around, okay? This stuff gets around. It doesn't stay on the battlefield, it goes everywhere. And these little particles this is a 200 nanometer particle, just gets straight into the cell. This is a study that was carried out in the United States. And these are uranium particles these are particles that can get into the cell. These are not uranium particles. I think these are plastic particles, but it just shows you that size of particle can get into the cell. Next slide. Okay, so then there was some evidence I got from my colleague, Dr. Al-Ali, on childhood cancer in the southern Iraq after the Second Gulf War. After the first Gulf War. In fact, you can see that the increases in lymphatic cancer and leukemia went up significantly after the Gulf War, the first Gulf War. There, look at the numbers, you see. So you go from 15 to 70 in terms of leukemia. So that's quite a significant increase. These are numbers. Okay, next. And so yes, this is a study that I did. I was involved in relating to lymphoma in the peacekeepers who had served in Kosovo and Bosnia, and you can see same thing sort of happening here. Lymphoma, a significant increase in lymphoma. I mean, not an awful lot of cases, but then it's quite a rare. It's not a very common disease. And Hodgkin's disease, not Hodgkin's lymphoma, is not significant there. But there were reports on the TV that there were significant increases in Italian, Spanish, and Portuguese peacekeepers. These are the people who were in the area where the DU was used. We had a map, and eventually we got a map from the Americans on where they did fire this stuff. But then the Italian government got concerned about this, and they ordered another study, and so they went off and did the other study, and when they finally produced the other study, they suppressed it. So we don't know what happened, but presumably the rates were very high. I think I heard from somebody who had seen it that they were so high that they just wanted to cover it up as quickly as possible. The world now is just completely run on the basis of cover-ups. Okay, next slide. All right, so we also, yes, we found depleted uranium in Gulf War I veterans' urine, or rather Durakovic did. And the depleted uranium board did not find significant DU in the Gulf War I veterans. So there's some problem there, but I helped to write the DUOB report. It was a report involving there was a sort of minority report that I edited. There were problems associated with the methods that were being used. Anyway, you can see it if you look online for the report. What I said, it's quite complicated. Then depleted uranium was found by Nick Priest in 20 members of the population of Kosovo in 2001, including his own cameraman, and they'd only been there for a week or two. Then Asaf Durakovic reported high levels of uranium in Afghans. The Japanese found high levels of uranium in children near Basra. And the UK military supplied me with figures showing high levels of natural uranium in urine in Gulf War II veterans. Next slide. These are the isotopic ratios. Yeah, we're not interested in that. Next slide. Okay, so yeah, so that the woman Heike Schroeder, she did chromosome testing. So she looked through microscopes at chromosomes of Gulf War veterans, and she found that there was a correlation between the chromosome damage in Gulf War veterans who had depleted uranium in their urine. So in other words, they got the same guys who gave the high levels of uranium in their DU in their urine as measured by Durakovic, and they sent blood samples to Heike Schroeder, and she looked at the chromosome damage and found they all had chromosome damage. And sent back to Miller, of course, she found uranium giving large, unexpected, and anomalous effects. And then we're back to the photoelectron explanation. Next slide. Okay, well, uranium in the environment has been going up ever since then. I mean, if you look at the Aldermaston measurements, they're still going up. They went up after the Gulf War, and they're still going up. There's sort of almost continuous, very slight increase in uranium in the air since the Second Gulf War, and we see it all over the place wherever we look. So there was an increase in the water supply of Los Angeles. Because nuclear power stations also produce uranium. Every nuclear power station releases uranium particles normally. It's a sort of part of their license to kill, as it were, you know. So uranium particles in the environment have been just continuously increasing, and of course so has cancer. Right, next slide, please. All right, so this is Lebanon. So this is about the new weapon. I'll briefly whiz through this. Okay, so I was contacted by a member of the Lebanese Academy of Sciences who looked at a crater in the Lebanon with a Geiger counter, and he found that it was radioactive. This was at the time when the Israelis were dropping bombs and shooting missiles in Lebanon in 2006. And so he got on to me and said, "What's going on?" And I sent my friend Di Williams out there to take some samples, and he took some samples, brought them back. And also we took samples of dust from vehicle air filters. That's when I started looking at vehicle air filters. Next slide. Yeah, so this is an ambulance that was in Beirut at the time when the Lebanese dropped some missile into a big bunker and destroyed everything in the bunker and all the people there and everything. So we thought we'd have a look and see what was in the air filter from the ambulance. So we pulled out the air filter and brought it back to England, and we shook the dust out of it and sent it off to the laboratory to be examined, and we found uranium. But this time it was enriched uranium, not depleted uranium. Next slide. So, and also we found hot particles. This is a sort of photographic method for looking for particles that give off alpha. So this is behind this is these little bubbles are alpha particle tracks, and the particle you can't see it's just making those tracks. We exposed it for 14 hours. It's obviously a uranium particle. So there were uranium particles in the air filter, but they were not depleted uranium. They were enriched uranium. Next slide. Yes, so I'm just saying that they're strange new radioactive weapons. So the Lebanon has saw the deployment of new weapons which contain both enriched and depleted uranium. We did a lot of measurements on this, so there's no argument about it. We had two different laboratories use two different techniques to look at the nature of the uranium in these craters and in the air filters. And they started to use this stuff in Gaza as well. There's some horrifying pictures of the effects of these weapons, which I decided not to show you. Next slide. Oh my God! Yeah, next slide. Those are not horrifying pictures. Those are just normal pictures. So let's go to Fallujah, because Fallujah is the key to all of this. I mean, the rest of it is pretty much arm waving, but in Fallujah, I actually I was involved in 3 studies, which were all published in the peer review literature, and which led to an enormous argument at the highest level in the United Nations about the health effects of depleted uranium or uranium weapons. And so these 3 studies, which were all published in the peer review literature, form the basis for the current assertions that DU is a serious genotoxic health hazard. So when people say, oh, you know, and you'll see lots of stuff on the internet about this, about, oh, DU is very dangerous and DU causes this and DU causes that. All of these assertions, although they never mentioned my name, were based on studies that I did between 2010 and 2012, which I'll just briefly look at now. Next slide. These are the 3 studies. The first one was in the International Journal of Environmental Public Health. That was the one that gave the high levels of cancer and the basis for the assertion that these uranium weapons are causing effects similar to Hiroshima, and it's an accurate assertion. Then the second one was a congenital anomaly paper that's showing that there were enormous levels of congenital anomaly in Fallujah following the use of uranium there. And the third one, it proves that it was uranium, because what we did then is we took the hair out of 20 women whose children had congenital malformations, and we dissolved it in acid and then shot it down a machine that measures the atomic mass. mass spectrometer, inductively coupled plasma mass spectrometer, in which you can show how much of any element there is in any sample. So those are the three papers. Now, next slide. So the first paper reported the results of this epidemiological survey of Fallujah, looking at infant mortality, sex ratio, and cancer. These are all things that we would expect to find if there was genetic damage. And results showed a remarkable and statistically significant increase in infant mortality, and there was a large sex ratio change from 1,055, which was the normal level. That's one in all human populations. You've got 1,055 boys to 1,000 girls, and it switched to 870 boys to 1,000 girls. So it was a complete rearrangement of the sex ratio at birth, showing genetic damage. And then the cancer rates were enormously high too. For leukemia, for example, there was more than 30-fold increase in relative risk compared to Egypt and Jordan. Next slide. So this is, I mean, I've just put this up. I'm not going to talk through it, but you know, for the purposes of republishing this, if anybody wants to know, this is taken from the paper, and you can see, for example, here we've got highest risk for all leukemia in the age group 0 to 34. We've got 20 cases, relative risk 38.5. That's almost double the amount they found in Hiroshima, and that was the origin of the assertion that we see on the internet that this is like, you know, Iraqi's Hiroshima. Next slide. Then this is the first paper, infant mortality based on the mean birth rate over the 4-year period and so on, is also very high. 80 deaths compared to 17 in Jordan and 9 in Kuwait, and the best sex ratio. So next slide. And so the second one was looking at the birth defects, and basically there were a lot of them. I mean, I'm going to go waffle my way through all of these, but they're there for anyone who wants to see. And the papers are all online, so you can find the papers as well. But this is sort of abstract, okay? So they found all sorts of congenital malformation. And you see, like, congenital malformation here at the bottom, it says 113 heart and circulatory system cases. Now, if you have a baby and it's got heart and circulatory system congenital malformation, there's no little, you know, tattoo on its head saying congenital malformation. What happens is it cries a lot, it doesn't drink milk, and it dies. And you think, oh dear, my baby's died. And then you weep about it, and then you think boo-hoo, and I don't know, whatever. Your mother is a terrible thing, or if your father, it's a terrible thing. But you don't know that it's a congenital malformation. So if somebody comes along afterwards from the Iraqi Ministry of Health, say, have any of your children died of a congenital malformation? You say, no, my child just died. And they say, right, no congenital malformation, you see. So that's the origin of the arguments that were leveled against what it was we did by the Ministry of Defense Ministry of Health in Iraq. Next slide. And so, well, so here we are. So this is approximately comparing it with Kuwait and the Emirates. You know, so we've got a rate of between 48 and 144 per thousand births, compared with 31 and 12 in Kuwait and 7.9 in UAE. So lots and lots of congenital malformations. Next slide. And that's just what we said about it. So basically what we said as a result of that was, you know, it's a terrible thing, lots of dead babies, lots of cancer. What's the how did this come about? And that takes us to the third paper, which is the next one. Next slide. So what we did then is, as I said, we looked at the hair and we measured all of the elements. We measured 52 elements, you know, in barium and calcium and copper and phosphorus, and you name it, they're all there. And we didn't find anything apart from high levels of uranium that could have caused congenital malformations. So we more or less rule out everything else except the uranium. So here we have 3 papers, which are papers relating to data, not papers relating to saying, you know, oh my dear goodness me, uranium's bad and I don't like the Americans or anything like that. This is just numbers, just numbers. And the numbers show for all time that if you used uranium weapons on a population, you get hugely high levels of cancer, hugely high levels of congenital malformation, a lot of dead babies, and total genetic damage, which continues, which is because, of course, the uranium is inside the people, and so it doesn't stop there. And they're still having high levels of congenital malformation now. I've talked to the doctors there, the pediatricians that I worked with there, Dr. Alani, who has basically got all the data for us, and which shows all this stuff, and that's still happening. That's still happening. It doesn't go away. Next slide. Next slide. Okay, Dyson. Well, the question is who believes what? So I was asked to give an expert analysis of the possibility, of the question that this guy Dyson, who was a UK Gulf War veteran who cleaned tanks, died from colon cancer, and this time it wasn't just going before a judge. This was a coroner's jury, so we had a proper jury case to find out why this guy died. And the Ministry of Defence sent their expert with all his arguments about how uranium can't cause cancer, can't kill people and cause genetic damage and so forth. And I gave all my evidence, more or less what I've just said to you just now. And the jury found that Dyson's cancer was caused by depleted uranium. So this is a very strong case. This is like a law court with a jury, and they found that depleted uranium causes cancer. But of course, the Ministry of Defence still argued that it doesn't cause cancer, and they just ignored it. Next slide. So I've been involved in lots of other stuff, but there's not enough time to really discuss it all. And I want to sort of quickly go off and to talk about today, to what's happening now. Okay. So next slide. So as I said to you, I found that uranium, I almost said Ukrainium there, getting tired, found that uranium had migrated from Iraq to Aldermaston. I showed you those pictures. That got into the newspapers. That was front page on the Times, I think, or the Telegraph. But so I decided last year to have a look and see what was happening in Ukraine. Nobody had said anything about uranium weapons at that point, but I thought, well, let's have a look. So I did. So next slide. Well, what I found was there was a statistically significant increase in uranium in all of the Aldermaston filters beginning immediately after the war began in February 2022. This meant that uranium weapons began to be employed as soon as the war began. Who was using them? I mean, well, we don't know. But anyway, so I wrote a paper which I sent to the journal, International Journal of Environmental Research and Public Health. It's the same journal that published the Fallujah stuff. And they threw it out immediately. They refused to publish it. But this is official data from official sources measuring uranium in the United Kingdom. And it showed an increase. But this is a scientific journal, and they were refusing to publish it. Why? So then I sent it to the other journal, Conflict and Health. Those were the people that did the uranium in hair, I sent in Iraq. And so they sat on it for about 3 months and then rejected it suddenly without sending it for review. But nowadays you can put stuff up on the internet. Hurrah for the internet. So they have a preprint site where they allow you to put up, they encourage you to put up papers before they get sent to the referees, to the reviewers. So it went up there, and it was immediately downloaded by more than 4,500 people. So nowadays it's not so important to science is in a mess at the moment, but it's a bit like the universal media. It's the reason why basically I'm here talking to you guys, because to try and get anything out into the media nowadays is pretty much impossible if it's something they don't want to hear. Next slide. And so these are the results. So this is, now if you see here, when we're at about 0.55, I don't know if you can read these numbers at the bottom. These are just numbers relating to the weeks after end of 2017. So it starts to go up almost immediately. This is the first time it goes up here, where you see it starting to go up is the 28th of February 2022. And that went up and up and up and up. And then towards the end of 2022, it came down for some reason. So what it suggests is there was a lot of uranium weapons being used at the beginning in the tank battles that there were at the beginning of the Ukraine incursion of the war. And then whoever it was that had these weapons ran out of uranium. That's what I would guess, you know, being Sherlock Holmes. So they'd used all their uranium weapons up and they didn't have any more. But the point about this is it's coming to the United Kingdom. It's being measured in Reading. This is 1,800 miles away from Kiev. Okay? It's a long way. And so it just shows this stuff gets around. And of course, anybody in Reading, and not just Reading, of course, but everywhere in the United Kingdom where this stuff went, was inhaling this stuff. And it will produce cancer. Some people, there'll be a higher cancer rate. There'll be probably lung cancer. And there will be some problems with genetic damage in children and all the rest of it. And I should be interested to see what happens now that the Khmelnytsky explosion has occurred and more of that stuff has come here, as I understand it. But of course, by now they might have cottoned on to me and just be covering it up. That's what's most likely. Next slide. So back to this one, Khmelnytsky. I'm not sure if I've written this. I did this in a hurry. I'm in Berlin at the moment, and I've just got here, and I knocked this together really quite quickly. So that might be a misspelling, but anyway, since it's transliterated anyway from the Russian. So there was a great bang on the 13th of May. Everybody's seen it, I think, on the internet. And it looked very much like a depleted, like a uranium explosion. It produced also a lot of black smoke. And so this is consistent with the assertion that it involved uranium weapons. This is what everybody said. And the other thing that I haven't written down here is that after this happened, they cleaned it up with robots. So we have pictures on the internet of the Ukrainians going in there clearing up the explosion site with robots. The question is, why do you need to have robots if it's not radioactive? The radiation detection system, Uralos, was inaccessible shortly after the event. So we went in there trying to find increases, or looking to see whether there was anything happening, and it was shut down. But by that time, I had some data, thanks to a lady who I worked with called Dr. Deepti Bisht from Cambridge. Next slide. So, this one actually, if you press a button, it shows the explosion, but it doesn't matter. Anyway, it was an enormous explosion, and that's a picture of it. So next slide. And so immediately what happened shortly after that, there was a sharp increase in radiation at these detectors in Poland to the northwest of the explosion site. And this is one such increase, which is an increase from 60 to 90. So that's about 50% increase in gamma radiation. Next slide. And so it's also occurred more or less across Poland at slightly different periods of time, consistent with the distance from the explosion site. And I mean, of course, that you can get increases due to radon. Sometimes if there's a thunderstorm or there's a lot of rain or something, it flushes radon out of the ground, and you can get some increases due to radon daughters. But I looked at I looked quite closely at the meteorological picture at that point, and there was nothing untoward. There was nothing strange. It was a big anticyclone there. The wind was blowing from the southeast to the northwest. It was very, very little wind, about 5 knots, something like that. And there's no reason for a radon spike. So this is a real radiation spike. I can't say that it's uranium. I can't really say anything about it, but there was an enormous explosion, and then there was an increase. Next slide. I was contacted by a man in Göttingen who was woken up in the night because he was paranoid, like me and like many people, about radiation, and he bought a little Geiger counter which he set on an alarm setting. And suddenly the alarm woke him up at 3 in the morning. And he sent me some pictures of what he got. He said it went up to 112 microsieverts per hour. Now that's a pretty high level of radiation. And so if we believe what it is he sent me, and I've got no reason to suppose that he was making it up, then there was some spike in radiation that occurred shortly after this Khmelnytsky explosion. Of course, I don't know if it was a radiation explosion. I don't know if it was uranium. But I'm saying that I think it was an increase in, for all sorts of reasons, that there was an increase in radioactivity, probably from the uranium, probably from weapon storage, and probably it's contaminated the whole of Europe.
Dr. Busby. Hello.
Yeah, hello.
I think we're very close to running out of time here. I'm trying to find out how much more time we have the connection for.
I'm pretty much finished here.
Okay.
I think I had a sort of final arm waving thing to say here. Conclusions that, you know, the conclusions are pretty obvious from what I've said so far. Is that one thing? The thing we know is that there is uranium here from the Ukraine war already, and then there probably is from the Khmelnytsky explosion, and the effects will, if it gets used to any great extent following the firing of the American and the British uranium weapons, it will just be more of the same, really. And what we must expect as a result of that is what we found in Iraq and Kosovo, and that's not good.
So is there any time for questions, or? I think we've got like 3 minutes.
Well, next slide then.
Okay.
I just wanted to say that if you look at all of this stuff, not just the uranium, but if you look at the whole essence of the problem, which is the health effects of internal ionizing radiation, you find that there's been enormous cover-up, a systematic cover-up from more or less the beginning, from more or less 1952, when they started blowing all this stuff up in the atmosphere. And you will also realize, or anybody sensible will realize, that they can't afford to concede that there's a problem, because if they were to do so, then their nuclear energy systems would have to stop. People would, with cancer, would topple governments. The court cases would go mad. The thing is that they've dug themselves into a corner. When I say they, I mean the authorities, the military, the global power structure, whatever you like to call it. And so the cover-ups are becoming increasingly hysterical and shrill and obvious. And you know, and this issue of internal radiation and the failure of the risk model is now coming to a head. I mean, and people are now letting me publish this stuff in peer-reviewed journals. But you won't find me much on the internet, except to find me being attacked and reviled and ridiculed and made to look stupid. But I don't care. I just soldier on and do my best. And eventually, like everything else, these things will emerge, but maybe too late to save an awful lot of people, because there are a lot of very horrible, dishonest, bad scientists who work for a horrible, dishonest, bad system that's aimed at making money and retaining power. And I think all of the people in peace groups and so on realize this, but nobody seems to be able to do much about it. But my method is to attack them through the methods that they use, the science that they use, and to push them off their horses, their scientific horses. That's all I can do.
Well, thank you very much, Dr. Busby, for your sobering presentation on the uranium weapons and the effects that they have had and the effects that they may have, will have, if they are fired in Ukraine in the course of this war.